Okay, so here we have the sine of theta. Is that, in fact, let me write that out so you can see it more easily. They're saying the sine of theta is negative 1161 61ths, and then pi theta 3 pi over 2. That's what this is saying. So theta is between pi and 3 pi over 2. Okay, use this information, find sine of theta over 2. That's what they want me to find. Sine of theta over 2. Okay, well, if that's what they want me to find, let me start there. So the sine of theta over 2, that's what they want, right? That's what they're asking for. So let's just go to the formula sheet and find out the formula for sine theta over 2. Here it is. We're down here in the half angle formula. Sine of x over 2 plus or minus square root of 1 minus cosine all over 2. All right, back to it. So that's easy enough. It's plus or minus square root of 1 minus the cos of theta all over 2. Okay, so notice the sine of theta over 2, half of theta, half angle, is 1 minus the cosine of regular theta all over 2. It's plus or minus. So this tells me right here I need to find cosine of regular theta, don't I? I don't have that right now. I have sine of regular theta, but I need, in order to find sine of half of theta, it involves using cosine of regular theta. So I need to find cosine of regular theta. How am I going to do that? To find cosine of regular theta, draw the triangle in the correct quadrant. Find the quadrant using all students take calculus. Remember that way of knowing where the signs are positive and negative? So let me come over here. Let me draw the axis system. And remember, it's all trig functions are positive in the first quadrant. Students take calculus. That's how you remember which trig functions are positive in which quadrants. Now, what are they saying to us? Right over here, they're saying sine is negative, right? Sine's negative. So we're not here and we're not here because sine is negative, right? They're all positive here and sine's positive there. So we're not in the first or second quadrant. Now what does this say? This says theta is between pi and 3 pi over 2. So actually that just tells me directly, doesn't it? Look at the unit circle. Yeah, I don't need to mess with anything else like that. I didn't even notice that. Here's pi, and here's 3 pi over 2. So the angle is somewhere between these two, between pi and 3 pi over 2. So it's in the third quadrant. It's clearly in the third quadrant. So yeah, so let me back up here. I don't need to use all students take calculus or any of that stuff. In the correct quadrant, I can just get rid of all this and just say third quadrant from this information right here. Okay, so I'm going to draw a triangle in the third quadrant. Remember how we draw these triangles. Triangle from the origin to the x-axis. So I'm going to draw the triangle from the origin, not to the y-axis like that. Remember, we always go to the x-axis. Why? Because 0 degrees starts at the x-axis, not the y. They just, by random choice, they decided to make all angles start 0 degrees at the x-axis. They could have made it straight up at the y. They didn't by random choice. And because they made them all start on the x-axis at 0 degrees, we have to make all of our triangles go to the x-axis, not the y. And that's because the angle we're talking about here, theta, really is from there all the way to there. That's really what theta is. But we'll just stick theta right here Yeah, let me back that up. That isn't so well done. Theta is really from there to there. That's really theta. But we'll just stick theta right here. This is really a reference theta. It's not the actual theta. Really theta, like all angles, has to start from 0 degrees and go all the way to this line. But we'll just stick our theta reference angle right in here and have it go to the nearest x-axis, and when you do, all the trig functions will come out the same. The sine, cosine, tangent, all the values will be the same. That's why we have to do. If we made that theta go here to the y-axis, the trig functions would not come out the same. So that's why we've got to go to the x-axis. Okay, number 2. Find two sides by the whole SOHCAHTOA. Right? Sine, opposite over hypotenuse. So this is opposite over hypotenuse. So here, this side here is opposite. This is the hypotenuse. This is the adjacent side, right? Opposite is negative 11, so this is negative 11. Hypotenuse is 61. Just getting those right here, right? Opposite is negative 11. Hypotenuse is 61. Okay, remember hypotenuse is always positive because it's just a distance from the origin. This one's negative because remember, from the origin you go back and down. So this guy's got to be negative. This one's also going to be some kind of negative number when we find it. It's back. In fact, why don't I just put it right here now? Negative number, because it's back and down. So now, step 3, what are we going to do? We've got to find the third side by, you know, a squared plus b squared is c squared. So let's do it. A squared plus b squared is c squared. So what's the c? The c is the hypotenuse. The a and the b, it doesn't matter. You can put those in either order. Whichever one you want to call this one a or the other one b, whatever. So this is 121 plus b squared is, I have no idea, 61 squared. Use your calculator. 3721. It's a big number. Subtract 121 from both sides. Boom. So b squared is 3600. And then square root that. Square root. B is 60, isn't it? 6 times 6 is 36, and 0 times 0 makes 2 zeros. 10 times 10 is 100. Right, so 60. So b is 60. So that means we can come up here, and we already had the negative on it. We knew it was negative, remember, negative 60. Now, the equation didn't tell us negative. That's not its job. Really, square root means plus or minus. It could be either one. The geometry tells you it's back 60, down 11 to get to that angle. It's left and down. Left is negative, down is negative. All right, so they're both 60. So we found the third side. Now we're almost there. What are we trying to do? All of this work is because we're trying to find cosine of theta. So now, find cos of theta by the SOHCAHTOA. Cosine is adjacent over hypotenuse, right? So cosine of theta, adjacent over hypotenuse. Go to that triangle that we just finished. Adjacent, negative 60, that's the one we just found, over hypotenuse, 61, right? Here's angle theta right here. Angle theta, adjacent over hypotenuse for the cosine. Negative 60 over 61. So there's the cosine. So now we can bring down this formula. Going to need a little more space here. So, okay. So let me go up here. I'm going to grab this formula. And I'm going to rewrite it down there because that's where we were at. So we were trying to find the sine of theta over 2. And it's plus or minus the square root of 1 minus the cos of theta all over 2. I did all that work to find out that the cos of theta right here is negative 60 over 61. So, almost there, sine of theta over 2 is plus or minus square root of 1 minus, careful, minus negative 60 over 61. It's going to end up plus there, isn't it? See how we have the minus from the formula and the minus that we plug in because of cos theta. So double negative is positive, as you know. So this will become plus or minus the square root of 1 plus 60 over 61 all over 2. All right, super close now. Now what are we going to do? Well, we have got to get rid of the, can't have fractions over, see how we have fractions over fractions? You know what to, we've had to do this a million times, right? Fractions over fractions, what do? You multiply all the terms, top and bottom, by LCD over 1, right? All the terms, top by LCD over 1. What's the LCD? 1 of each type of item under the small bar. So I look here and I go, okay, here's the small bar, that's what's under it, right? This is the big bar, not talking about that. I'm talking about the small bar, 61. All we got 61. So what am I going to do? I'm going to multiply it by 61 over 1. 61 over 1. 61 over 1. Top and bottom. Where are we at? 61 times 1 right here is just 61. Plus, these guys cancel. 60 over 2 times 61, 122. Oh man, I messed that up, didn't I? 122, right? 122. There we go. Okay, and so we're close. Plus or minus square root of 121 over 122. 121 over 122. Now we've got to figure out, is it plus or is it minus? What's up with this? Theta over 2? So I know this is not easy problem, is it? Right now we have sine of theta over 2 is that, right? So is it plus or is it minus? Well, it depends where the angle theta over 2 is. Let's go back. What do we know about theta itself? Theta itself, remember, is between pi and 3 pi over 2. So let's go back and put that information down. Theta itself is between pi and 3 pi over 2, which is 180 and 270, right? That's where theta is. Where am I getting that? Pi is 180, 3 pi over 2 is 270, right? Right on the unit circle. Pi is 180, 3 pi over 2 is 270, right? Okay. So now let's divide through by 2. Why 2? Because I'm trying to get theta over 2. So this is 90 theta over 2. Oops, messed that up, huh? And this is 135. Do you see that? So theta over 2 is between 90 and 135. Theta over 2 must be between 90 and 135. Where's that? Well, here's 90. Here's 180. This is 135. You can look on the unit circle. Yeah, I could just do that, huh? Here's 90. Here's 135. There's 90. There's 135. So our theta over 2 must be somewhere in that region, right? Between 90 and 135. Somewhere in that region. So what? Well, that tells us the sign. All students take calculus. In the second quadrant, sign is positive. Sign is positive. This is the sine of theta over 2. It's the sine of an angle in the second quadrant. Theta over 2. Theta over 2 is somewhere there in the second quadrant. So the sine of theta over 2 has got to be positive. That answer. So it's positive that. Now, one last thing. I know this problem never seems to end. I'm going to put the square root on the top and on the bottom. Why? Because I believe you can square root that number on the top. Yeah. That's just positive 11. And the square root of 122, I'm just going to leave that down there. And there we go. There is our answer. Like that. I believe they would also take it like this. I think either one of those is fine. They're both right. You can see I took the square root to the top and or this one. Really, you could do this one too. These are all good. This one this last one's a little cleaner because I did square root. The number on the top, the 121, can be square rooted. So I square rooted it with my calculator, got 11. The bottom number, 122, if you square root it, it's a big old decimal. So the root just has to stay there. You can't root the 122. So there we go. That was a lot of work, wasn't it, to find the sine of theta over 2. We had to get out the we do all the triangle work to find the cosine of theta. And then once we found the cosine of theta, we plugged it into the half angle formula, got this, tried to clean it up, got to this, figured out the sign had to be positive because of where theta over 2 sits. If we knew theta itself was between 180 and 270, divide through by 2, theta over 2 was between 90 and 135 in the second quadrant where signs are positive. That's how we knew it was positive. There we go.